Here's our coordinate plane review for today. Our quiz is tomorrow. This first problem, we're going to write an equation of a circle centered at -4, 6 with a diameter of 16. So -4, 6, the coordinates of our center, we'll substitute those for h and k into the general equation for a circle. The diameter is 16, and the diameter is twice the radius, so we'll divide by 2. The radius is 8. So we'll use x minus h squared plus y minus k squared equals r squared, and substitute h, k, and r into the equation. This gives us x plus 4 squared plus y minus 6 squared equals 64. Again, this sign changed because I substituted a -4 minus negative becomes plus, and then I squared the 64. The next problem, we have write an equation of a line that passes through a given point and is perpendicular to y equals -5 halves x plus 1. So our perpendicular line will have a slope that is opposite reciprocal to the line given. So our given line has a slope, we have our negative here, hanging off on this side, and 5 halves on the other end. So the slope that we're given for our line, m equals -5 halves. The perpendicular slope to that is positive 2/5. So we're going to substitute this perpendicular slope, this is the slope we want to use, the perpendicular slope, we're going to substitute that slope into the equation of the line. I'm going to use point slope form. You can also use slope intercept form, solve for b and substitute it back in. I'm going to use point slope form, which is y minus y1 equals m times x minus x1. We'll substitute the perpendicular slope into our equation, and we'll also substitute the ordered pair, the x and the y. So this will go in for our x1, and this will go in for our y1 into our equation. So we'll substitute slope here, y minus -3 equals 2/5 times x minus 5. Then we'll distribute 2/5 and simplify the double signs over here to get 2/5 x minus 2. After that, we want to isolate y, so subtract 3 to the other side of the equation, and that gives us y equals 2/5 x minus 5. For number 3, we're going to calculate the distance between Reed and Skylar. It says that they're playing hide and seek and they run in opposite directions, and we want to find out how far apart they are. I just drew a quick little sketch on my paper just to get an idea of where they're located. North, south, west, and east. Of course, we're also going to consider these as the x and y axis and mark them with negatives and positives accordingly. So Reed runs and hides 30 feet south, so he's going 30 feet in this direction. So that's -30, and then 24 feet to the east. So here he is at +24, -30. And again, I'm labeling these, x-axis first and then y. Then Skylar runs and hides 43 feet north and 12 feet west. So -12, 43 would be the coordinates for Skylar's location. So then in order to calculate how far they are apart from one another, we'll use the distance formula. So d equals, that's x2 minus x1 squared plus y2 minus y1 squared, and we'll substitute the coordinates of the points. It does not matter which is the first point and which is the second, as long as you subtract them in the same order for both. So we'll go ahead and substitute our values into this formula. So we'll have 24 minus negative 12, and then negative 30 minus 43 quantity squared, and we'll subtract those first and then square, so that gives us 36 squared plus negative 73 squared. That gives us 6,625. Take the square root of that, and they are approximately 81.4 feet apart from one another. Alrighty. Number 4, a circular skylight has a diameter with endpoints at negative 632 and 226. We want to find the center and the radius of the skylight. I'm going to start off with the center. The center is also the midpoint of the diameter. So we'll substitute these ordered pairs into the midpoint formula. The midpoint formula is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. We're just taking the average for the x's and the average for the y's. So that's going to give us negative 6 plus 2 for the x's, and then 32 plus 26 for the y's, giving me a midpoint or center of negative 229. So that's the center of our circle. Next, we're going to take that center and we're going to use it to find the radius. To find the radius, that's going to be the distance between the center and the end point. And we can use either end point. Those are the end points for our diameter, so one end is, or one half of that is the radius. So here we go. D equals, and we'll substitute one of the ordered pairs and the center into our formula. So that's going to be, actually, instead of calling it D, I think I'll call it R since it's the radius. So R equals negative 2 minus 2 squared plus 29 minus 26 squared. That gives us negative 4 squared, which is 16, and 3 squared, which is 9. Square root of 25 is 5. So our radius is 5. On number 5, we're going to find the perimeter of this figure. Luckily, a couple of these lines are lined up right on the grid lines, and we can just count the length for each of those parts. I'm going to name the corners or the vertices of this figure just so that I can write them down. So I'm going to call this figure A, B, C, D. And so the length of side AB, I'm going to count that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So AB is 9. Now to find BC, I'm going to make a right triangle and use the Pythagorean theorem. So BC squared, and then I'm going to use a squared and b squared. So BC is my hypotenuse. 1, 2, 3, 4, 5. And then 2 for the top. That gives me 25 plus 4, which is 29. Now we got to square root that. So BC is the square root of 29, which is approximately 5.4. Now we'll find the length of CD, which is 9. And then we'll find the length of AD, and again we'll use the Pythagorean theorem and create a triangle here. That's 1, 2, 3, 4, 5, and 2 for the legs. So AD squared is the hypotenuse, and 5 squared and 2 squared is going to give us the same result as we had for BC. So we'll get 29 here, take the square root of both, and AD will be approximately 5.4. Then to find the perimeter of the whole figure, we'll add the 4 sides together. 9 plus 5.4 plus 9 plus 5.4 gives us 28.8 for the perimeter. Tune in to the next video to see the other side of the review.